These are the notes from section 10.3, which is on circles. Definition of circle is the set of points equidistant from a fixed point. So we have a fixed point somewhere, we call that the center of the circle. And the circle is all the points, the same distance from that point, that fixed distance, whatever that is, that's the radius of the circle. The general equation for a circle is x minus h, the quantity squared, plus y minus k. Quantity squared is equal to r squared, where hk is the center of the circle, and this circle's radius is r. So example 1 gives us an equation of a circle. It asks us to find the center, the radius, and then to sketch a graph. Like we did with ellipses, the center of the circle is hk. Remember, it's x minus h, so h is positive 3 in this case. My k value would be 0. So the center is at 3, 0. We can plot that on our graph. Equals r squared, so r is equal to 2. From the center, we go left 2, right 2, up 2, down 2. And from there, we should be able to draw a pretty good circle. It's not great right there. Example 2 asks us to write an equation for the circle given its center and its radius. We want the center to be at negative 5, 3. The radius should be 4 root 2. So if the center is at negative 5, 3, that means we've got x plus 5 squared and y minus 3 squared. That should be equal to the radius squared. If the radius is 4 root 2, I need to square 4 root 2. 4 squared is 16. Root 2 squared is 2. So equals 32. Example 3 asks us to write an equation for a circle given the center and another point on the circle. Write an equation for the circle with the center at 2, 1 that passes through the point 7, 3. So center is at 2, 1. We should be able to take care of that. Let's set that equal to r squared. There's a couple different ways you could get the radius. One thing you could do, the radius is the distance from the center to any point on the circle. So because we want the distance between these points, you could go back to geometry and use the distance formula. That would work. That would give you the radius, and then you could plug that in and square it. And that would give you r squared. Or probably an easier way, we've got an equation for the points on this on this circle. We know 7, 3 is one of those points. So we can plug this point in for x and y, and we should be able to solve for r squared then. So 7 minus 2 squared plus 3 minus 1 squared is equal to r squared. That's 5 squared is 25. 2 squared is 4. I get r squared is equal to 29. Looks like the radius of the circle is root 29. And there's the equation of our circle. And example 4 is one of these where it gives it to us in the big ol' expanded version. it wants us to graph this circle. First of all, you can tell this is going to be a circle because the x squared and the y squared term both have the same coefficient. They're both 1. I've got 1x squared plus 1y squared. If those are different coefficients, like 3x squared plus 4y squared, it is going to be an ellipse, or technically it could be a hyperbola. We haven't talked about those yet. But if x squared and y squared have the same coefficient, we know it's going to be a circle. First thing we need to do is change it to standard form. To do that, we are going to group the x's together, group the y's together, and move the constant over to the other side. Subtract 64 from both sides would give me minus 64 over there. We want to complete the square. We complete the square by dividing the b term by 2. Gives me minus 3. Squared is 9. I added 9 to the left side. I want to add 9 to the right side as well. 16 divided by 2 is 8. Squared is 64. If I added it to the left, I need to add it to the right. Factor this. Numbers that multiply to 9 and add up to negative 6. It would be negative 3 and negative 3, x minus 3 squared. Factor the y values as well, should be y plus 8. Add up our terms on this side, gives me 9. And now it's very similar to example 1. It gives us an equation. We should be able to graph our circle. Center is at 3, negative 8. Radius is 3. And that is the notes for section 9.3, which is on circles.